Today we're going to be looking at derivatives. Derivatives are the sensitivity of change in one quantity to another. For example, the derivative of velocity is acceleration.
Okay.
The three basic rules of derivatives are the constant rule, the power rule, the constant multiple, the sum and difference rule, and the product rule.
Okay.
Today we're going to look at the first three: the constant, the power rule, and the constant multiple rule. In the constant rule, if, as in any derivative equation, if y equals 2,
The function is a constant.
if a function has a constant, then the constant automatically becomes 0. For example, any number plus or minus 0, 2, 3, 4, negative 5, etc. For example, y equals 2, then the derivative of that would be y equals 0. Y prime equals 0. The power rule states that if y equals x squared, to find the derivative of that, you do y derivative equals 2x. This is because we take the power and imagine it as n. So x to the nth power. To find the derivative, you do n minus 1 and then n times x. So it would be nx to the nth minus 1 power.
Okay.
That's where we get 2x, because it's 2 minus 1, and we do the 2 times the x. So 2x to the first power.
Okay.
And the constant multiple rule says that if you have y equals 3x squared, you take the constant and you multiply it by the 2. For when you bring if it's 3x to the nth power, you would do 3 times n x to the n minus 1. And so your answer for this would be y equals derivative of y equals 6x, because 2 times 3 equals 6, and x 2 minus 1 equals 1.
Okay.
Now let's look at some problems. First, let's look at some constant problems. What would the answer be if you have y equals 2 plus x?
Okay, so 2 is a constant, so derivative of that would be 2 constants, that is equal to 0, and x to the 1, so that would be 1, but then it comes x to the 0, and anything to the 0 is 1, so this would be 0 plus 1, so derivative of y would be 1.
Okay, and what is the derivative of y if y equals 3 plus 2x?
Well, you have the derivative of that would be 3 becomes 0, and then 2x again, the x becomes x to the 0, which is 1, so it becomes 3 plus, or 0 plus 2, or derivative of y is equal to 2.
Okay, now let's look at some power rule problems.
Okay.
What is the derivative of y if y equals x to the third?
So derivative of that would be, you have to bring, n in this case is 3, so then you bring it down in the front, so it becomes 3, and then it becomes x to n minus 1, well n is 3, so then it becomes x 3 minus 1, which is 2, so it would be 3x squared.
Okay. And what is the derivative of y if y equals 1 plus x to the second?
So the 1 becomes 0, and then the x to the second, the derivative of y would be, it becomes 2, and then that would just be x to the first, so it would be 2x.
Okay, now let's look at some constant problems. Find the derivative of y if y equals 3x squared plus 1.
Well, the 1 becomes a 0, so then you bring the 2, so it would be 3x to the n, where n is equal to 2, so that would be 3 times 2 times x to the first, so 3 times 2 is 6, so it would be x, 6x.
Okay. Now let's try one more. What is y? Find the derivative of y if y equals 3x to the third plus 3.
The derivative of that would be, well, in this case, n is equal to 3, so it'd be 3 times 3 x squared, so it'd be 9x squared plus 0, because 3 becomes 0, so it'd be derivative of y is equal to 9x squared.
Okay, we have these for today. Tomorrow we'll go over sum and difference rule and product rule.
Okay, thank you, Brian.
Okay, yesterday we went over the derivative rules of the constant rule, the power rule, and the constant multiple rule. Today we will go over the sum and difference rule and the product rule. For the sum and difference rule, that's actually quite similar to the previous rules, as in if you drive the other stuff, but if you have, for example, 2x plus 3x squared, you drive those, but you keep the plus sign the same. So your answer would be 2 plus 6x. You just leave that the same.
Okay.
A difference rule means if that's a minus sign, then you just keep the minus sign the same.
So you're just taking a derivative of each term.
Yes,
Okay.
you're just keeping the sign the same.
Okay, that's pretty straightforward.
Okay. Now the product rule is where stuff gets interesting. If, for example, you have 2x times 3x squared, you then take each one. Let's call the left side A and the right side B. Let's just sort them in the groups. You would then take A on one side, 2x, then derive that. So derivative of A equals 2, and then B equals 3x squared. Then you would do the derivative of B, which equals 6x. And then you do A times the derivative of B, which would be 2x times 6x. Then you do plus the derivative of A times B. So 2 times 3x squared, which then gives you 12x squared plus 6x squared, which then you can then add together because they're both squared, which gives you 18x squared. So the derivative of 2x plus 3x squared would be 18x squared. You have to do this because instead of being added, where you just derive each side, they're multiplied.
Okay.
It's similar to the FOIL method.
A little bit.
Yeah. Now let's go over some practice problems. For the sum and difference rule, if we have if y equals 2x squared plus 5x, what is the derivative of y?
It would be the derivative of each term, so in this case it would be 4x plus 5.
Yep.
Okay.
Okay, and what is the derivative of y equals 3x plus 4x to the third?
Again, it's just the derivative of each term, so derivative of y would be equal to 3 plus 12x squared.
Okay, and just one more.
Okay.
If y equals 4x minus 5x squared plus 2x to the third, what's the derivative of y?
Derivative of y would be the derivative of each term, so this one would be 4 minus 10x plus 6x squared.
Good. Now let's move on to some power rule problems. If you have y equals 2x squared times x to the third, what would your answer be?
Well, I have to find the derivative of each term, so the first term is 2x squared, and the derivative of that would be 4x, and the second term is x cubed, so the derivative of that would be 3x squared. So the product rule would be, the derivative of y then would be the first term times the derivative of the second term, which is 3x squared, plus the second term, which is x cubed, times the derivative of the first term, which is 4x. And then you multiply that all together and you get 6x to the fourth plus 4x to the fourth. And you combine like terms, you get 10x to the fourth.
Okay. Now let's just try one more.
Okay.
What's the derivative of y if y equals 4x to the third plus 2x?
This is just the basic.
Sorry, times 2x.
Oh, okay. So again, we'll have to find the derivative of each term. So term 1 is 4x cubed, with the derivative of that equals 12x squared. Second term is 2x, derivative of that is equal to 2. So then using the product rule, the derivative of y would be equal to the first, which is 4x cubed, times the derivative of the second, which is 2, plus the second, which is 2x times the derivative of the first, which is 12x squared. So now we do some algebra and combine them. Get 8x cubed plus 24x cubed. Combine terms, you get 32x cubed.
Good. Okay. Now that we see you have all 5 of the basics down, if you give me a second, I'll get the mini quiz and you can take that.
Okay.
And we can see how far you've advanced.
Thank you.
Here's the mini quiz.
Okay.
I'll just take these papers. And afterwards, we'll then go over the quiz and see how you did.
Okay.
And just to ensure you know the problems.
Okay. Show the work. What a novel concept.
Okay. Looks good. Let's just go over it for a second. Okay, as you probably guessed when I went through this, I put them into each part of the rules. I did the rule of the constant rule first, where we can see you did that pretty well. Y equals 2x plus 1. You got rid of the constant, of course the 2x becomes a 2. For the second one, we had y equals 4x plus 3. You got rid of the 3 because the 3 becomes 0. And it just becomes 4 because the x disappears. The second one here, we did the power rule. And so as we know, during the power rule, you bring the 3 down and you do 3 minus 1. So you did get 3x squared.
Okay.
And over here, this one was mixed up of the power and the constant rule. You did well, you got rid of the 2. And in the x squared, you brought the 2 down and did 2 minus 1, which gave you 2x. Over here, number 5 was a constant multiple rule, where, of course, it was mixed with the constant rule, and you got rid of the 2 correctly. And you did the power times the constant, so 3 times 3 is 9, of course. And you subtracted 1, which gave you 9x squared. And number 6, you had 2 plus 6x squared. You did get rid of the 2, like in the constant rule. And of course, 2 times 6 is 12, and 2 minus 1 is 1, so 12x, you got that. Over here, you did fairly well. You kept both of the signs the same. And you had, of course, 6x, which 3 times 2 is 6. That was similar to the one over there, which gave you 6x. And over here, we have plus 5x to the fourth, which is a derivative of x to the fifth, because minus 1, and bring the 5 down. Over here, number 8, this was sort of a combination of the top 3, where you got rid of the constant there. You got rid of the 1 there because you brought the exponent down, which is 1, and n minus 1 is 0, so that disappears, so it's negative 3. And of course, the 2 times the 5 is 10, and 10x minus 3, you got that correct. And over here, you had 3x squared times 2x, so you did separate it into a and b and found the derivatives and multiplied them together, which got you 18x squared. And lastly, over here, you had 4x squared times 2x to the third, where you did, of course, divide it off again, and your final answer was 6x squared. Okay?
No, my final answer was 8x squared times quantity 3 plus 2x squared.
Oh, sorry, yeah. Yeah, you took the 8x squared out of both sides, which then just gave you 8x squared, 3 plus 2x squared. Okay, overall it seems you get the subject matter.
Okay. Well, thank you, Dr. Davies. I enjoyed working with you, and I look forward to our next lesson.